Okay, this is Unit 7, Solutions, Lesson 5, and we only have about one more lesson left in this unit, so we will be having a unit exam next week. In today's unit, we are going to discuss all the types of calculations that we can do with solutions. These include molarity, percent by mass, percent by volume, and parts per million. So as we know, solutions are homogeneous mixtures. I've told you that before. Their compositions can vary, though. It is important for chemists to know the composition of a solution, and there's different formulas or methods that we can use to specify concentration, meaning the amount of salt in a solution of salt water. What is the concentration of that salt, the solute, per unit volume? The higher the concentration, the more solute that is dissolved in solution. So on the back of your reference table, you have a molarity formula that says molarity equals moles over liters. And one important piece of information that you need to know here is that sometimes they will give you the volume in milliliters. So 1,000 milliliters equals 1 liter. So you may have to do a conversion. So here's a typical example of what you might see. What is the molarity of a solution that contains 4 moles, so I know my moles, of NaOH in 0.5 liters. So molarity equals 4 moles divided by 0.50 liters. So that's going to give me 8 molar, and that is the concentration. I'm going to go through each one of these once, and then we'll do some practice ones. Parts per million is also a formula that is used to express concentration for very, very small quantities. We use this for, say, determining the amount of chlorine in a pool, or the amount of ions in a sample of water. So parts per million equals grams of solute over grams of solution times a million. And the million is the same as 10 to the 6th, so I'm going to write it as 10 to the 6th. In this example, approximately 0.0043 grams of oxygen can be dissolved in 100 milliliters of water at 20 degrees Celsius. Express this in terms of parts per million. If they give you milliliters in its water, 1 milliliter equals 1 gram. So this is the same thing. So you've got parts per million equals your grams of your solute, which in this case is going to be your oxygen gas, over your grams of solution. It's dissolved in 100 milliliters. So what you have to be careful of, if it's dissolved in 100 milliliters, then the total solution is 100 grams plus the 0.0043. So the mass of the solution is going to be the 100 grams plus the 0.43 grams, the total, times 10 to the 6th. So we've got 0.0043 divided by 100.0043, which really isn't going to change your answer any, times 10 to the 6th. And that's going to give you 43. The next thing that we have is percent by mass. And we've already looked at this, okay? Percent by mass is the same as percent composition. It's going to be percent mass is equal to mass of part over mass of whole times 100. So example, what is the percent by mass of sodium hydroxide if 2.5 grams of NaOH is added to 50 grams of H2O? So this is going to be percent mass equals 2.5 grams over 50 plus 2.5 grams. So it's going to be 52.5 times 100. And I get 4.76%. Percent by volume, we have the percent volume equals the equals the volume of solute over volume of solution times 100. So here we have percent volume equals, if we have 50 mils of alcohol is diluted with water to form a total volume of. Now this is important on the words because your volume of solute is your 50 mils, but this was added to make a total volume of 300. So we don't add the 50 to the 300 here, it's just 50 over 300 because that 50 is incorporated in this times 100. And that's going to give me 16.7%. Okay, let's look at a couple of other examples. If you have 5 moles of NaCl in a 2-liter solution, what is the molarity? So you know you're dealing with molarity equals moles over liters, and you have 5.0 moles over 2 liters. So 5 divided by 2 is 2.5, and that's the molarity. If you have 60 moles of HCl, what should be the total volume of solution to make a 10 molar solution? So now we have something a little bit different. Now they gave us this molarity, and they gave us moles, and we need to find this. So we can set up a proportion here. We have 10 molar equals 60 moles, and we don't know X liters, and we can just put a 1 here. So we get basically 10X equals 60, therefore X equals 6 liters. What is the concentration of a solution in parts per million if 20 grams of Na2S is dissolved in 4 times 10 to the 5th grams of water? So parts per million equals grams of solute over grams of solution times 10 to the 6th. So we've got parts per million equals 20 grams, and it's dissolved in this much. So that means you have to include that. So you've got 4 times 10 to the 5th grams plus 20 grams. So you've got 20 divided by 20 plus 4 times 10 to the 5th times 10 to the 6th. And I get 49.99. And that's because you're dissolving an awful lot of grams in a large amount of water. And that's your answer in parts per million. Now, I just want to show you some other type of problem that's not here. You could say, like, what is the amount of HCl needed to make 250 milliliters of a 3 molar solution. And this is a typical problem. So we know molarity equals moles over liters. I've got milliliters, which I can change to liters, and I have molarity. But it's asking amount, and amount implies grams. So this is a two-step problem. I have to use this formula, and I have to use this formula. So I've got my milliliters, and I've got my molarity. So I've got to change my milliliters to liters. So 250 milliliters. And I told you that 1,000 milliliters is 1 liter. So these cancel, and I'm going to get 0.250 liters. So my moles, or sorry, my molarity is 3 molar equals moles over 0.250 liters. I can cross multiply here, and I get 3 times 0.250, which is going to give me 0.75 moles. But that's not my answer. I need grams. So now I've got to go down to this formula, 0.75 moles. And I don't know the given mass, but I can calculate the GFM of HCl. So I've got 1.00794, which is the mass of H, plus 35.453 is going to give me 1.00794 plus 35.453 is 36.46094. So now I can put a 1 here, and I'm going to multiply that by 0.75. So the answer is 27.35 grams of HCl. So I'd have to go measure out 27.35 grams, and I'd have to dissolve it in a little distilled water, maybe 200 mils of distilled water till it all dissolves, and then bring it up to 250 so the whole solution is 250, and I will have a 3 molar solution. Okay, that's it for this lesson. Have a great night, and we'll do some practice problems on this in class.